Hello, good morning, good afternoon, good evening, whatever. Today, I will talk about algorithm group smart logistics management. Okay, and next I will show member to the project and role each person. Okay.
So my name is Kichira Thongrom. My ID is 670111153. So and my role are to make the slide from the past to the previous one, and also some of the presentation.
Hello, Professor. My name is Akala Wintam Pusakun. My student ID is 670111075, and my role is to do the flowchart and also do the presentation slides.
Is Natapa Pumlin. So my role is a programmer, and also I researching the problem of the logistic in Thailand, and research for the algorithm that can solve or help the logistic problem and apply it with the coding.
Hello, my name is Kawanom. Student is 6701148. In role I do is that I find a problem in logistic terrain and I find a solution to solve the problem and I find a unique selling point and I make a slide and I do in video editing. First, I want you to know the background of the project. In the high competitive world of logistics and daily ability to respond quickly and accurately to customer demand is a key factor that make the difference between being a market leader and falling behind. Today, I would like you to take you through the challenge that many business in this industry face and how we use technology to help solve this issue and improve logistic process. Okay, I will explain the problem we aim to solve, the method we use to solve them, and the unique selling point that make our system different from others so that you can see how the technology we use can help solve problems in this industry. First, we talk about the problem we address. In the logistics and delivery industry, companies face many challenges that directly impact operational efficiency and customer satisfaction. The first problem is order management. In real operation, when there are multiple orders to manage, ensuring that high priority or urgent orders are handled first is challenge, especially when dealing with stockout and delays. And the second is route optimization. Find the most efficient path for truck or warehouse staff, considering factors such as traffic, urgency, and distance is crucial to ensure effective delivery. Its third problem is inventory management. Tracking and storing large quantity of goods across multiple locations in the warehouse is an important issue for storage management can lead to difficulty in retrieving item quickly. The last problem is operational inefficiency. Okay, delay to process order, high transportation costs, and the route for manual operation lead to customer dissatisfaction and higher operational costs. When you know the problem, we will solve the problem. And what is solution? The outsolution concept is integrate several advanced algorithms to optimize the key operational area of logistics. The first algorithm is priority queue and greedy algorithm. This algorithm helps prioritize order and select the most available stock, ensuring urgent orders are fulfilled quickly and correctly, improving the order turnaround time. Its next algorithm is Digital algorithm. Okay, used for route optimization both inside the warehouse and for delivery to customer. Digital algorithm calculator shorter path, adjusting the real time for factors like traffic and delivery urgency, reduction delay, and fuel consumption. The last is Knapsack's problem. Dynamic programming. Okay. It is help maximize warehouse space by efficiently storing product based on their value and size. This ensures optimal use of available space and further retrieval of high demand item. Okay. Next is unique selling point. What makes our system different and unique is the integration of technology used in logistic management. Faster order management. By using priority quick and greeting algorithm, we can prioritize order and select readily available item, reducing processing time and improving customer satisfaction. Enhance warehouse space efficiency. Using dynamic programming to analyze item and optimize warehouse space help minimize the need for expanding storage or adding more storage area. Improve operational efficiency. The system enable real-time discussion making, ensure that business can operate more efficiently, reduce delay and lowering costs. Okay. By integrating this algorithm, business can improve logistic operation, reduce delivery time, save fuel, and increase profitability significantly.
So let's see in the inventory class flow chart. Yeah, if it's enter the start terminal, it will meet with the process of the initialize stock dictionary, and then it will meet the process of the subfunction of the update stock, and the subfunction of the check stock, the subfunction of the replenish stock, and the subfunction of the print inventory, and then it will meet it end. Now let's take a closer look in the update stock subfunction. So if you enter the update stock subfunction, it will make a decision: is the process exit in the stock? If it false, it will create the new entry of the products and then update the quantity at the location, and then it will meet it end. And if it's true, it will create the new entry products and then they will meet it end. Now the check stock subfunction, if it enter the check stock subfunction, it will make a decision: is a process exit at the location? It will return 0 and then it will meet it end. And if in another way, it will return the quantity and then it will meet end. Now the replenish stock subfunction and the print inventory subfunction, if it enter the replenish stock subfunction, it will check the stock for the product at the location, and then they will update the stock by adding the quantity, and then they will meet it end. And the print inventory subfunction, the loop through all the products and the location, and then they will print product and quantity, and then they will meet it end.
Well, the next class is flow optimization class. So it starts with initialize graph application dictionary. Then it's going to pass through the predefined process called allocation, and then it's going to add road and die star. After that, it's going to go to the decision block called priority queue not empty. If it's true, it's going to pop application with shortest distance, and it's going to loop and then turn back to the loop again. If it's false, it's going to check each neighboring location. It's going to update the distance, if shorter path found, reinsert update neighbors to priority queue. Then it's going to build the shortest path from end to start using your previous locations. And finally, it's going to return path and total distance. Now I'm going to talk about predefined process in the previous class. So let's start with the add location. It's going to work it by add location to dictionary, then add location to graph with empty adjacency lit, and then it's finished to works. And the second one is a Dijkstra. It's going to initialize the distance and previous locations, then set the distance for start location as 0. And the last one is an add route. There's a function to the calculate cost by distance multiplied by traffic and multiplied by urgency. Then it's going to add route to the graph bidirectionally. And this is all for this class.
So in conclusion, the smart logistics management address a key change in logistics like the efficiency.
Now let's talking about the priority queue class. It's starting by the initialize the heap as empty list. It's going to pass through the predefined process called insert. then pass along to the pop top is empty, search, delete, and print queue. After that, it does stop the works and the finishes. Define process called insert. It's gonna start by add order to heap, then heapify up to maintain order base to on urgency and stop the works. And for the print queue, it's gonna sort orders by urgency, then print each order details. And this is all for good. And let's go to the next slide for the next predefine process. For the pop, it's gonna pass through the decision is heap is empty. If it's true, it's gonna return none and finish the work. And if it's false, it's also the pop order with the highest priority with the lower urgency, and also finish the works either. The search is gonna work by loop through the heap and find the order by order ID. And another one is called top. It's gonna return top order from the heap without moving, and then finish the works. And for the another one is called is empty. It used to check if heap is empty and then return true or false. Last predefined process is called delete. It's gonna search for the order ID, then swap order with the last item, pop last item, then heapify down, and then they finish the works. And this is all of this class. Now let's gonna talking about the final class. It's called location class. The location class is gonna start by initialize location ID, name, and coordinates, and then it's gonna pass through by the redefined process called REPR, and then end the works. The function of REPR is gonna have to return location detail as a format string. Now let's continue of the location class. This flowchart is gonna talking about the function is called knapsack in the class location. It's gonna start by initialize DP table with the 0 values, then it's gonna loop through each item for each item weight limits. Then it's gonna check if item fits in the knapsack or not. If it fits, it's gonna choose that maximum value between including or excluding items. Then it's gonna return back with the max value for the full knapsack capacity. And this is all for the class location.
The part of coding, the first one we include the inventory class. First function is initial function. We like create stock by using the dictionary one, and the second one is update stock function. We will update the stock by that product name in that location, what is the quantity of it. They will update it to that location and this product name. So the next one is check stock. They will return the quantity of that product name in that location if they are having that product name. If not, they will return 0. The next one is replenish stock. So this will adding the stock that we have, if we have apple in the warehouse once quantity 10, and we want to add 10 more apple in that location, we use this function to add it in. And also this function will call the update stock to update the stock. So the last one is the print inventory. They will print all of the product name we have, and the all location that product name is in. Example is if we have apple in warehouse 1 and warehouse 2, the quantity is 10 and 20. They will print apple, product name apple. Warehouse 1 have quantity is 10 apple. Warehouse 2 have 20 apples. And if they have another product, they will going to loop again. The banana have in warehouse 3 for 25 bananas, like that. And next one is route optimization class. So the first one is initial function again. So they will create the graph or mapping and the location of it, and they will install or the load or loading the inventory information from the inventory class. And the second one is add location function. So this will like localize the path to the graph and waiting for connecting to another location or some point, yeah, with the empty list, yeah. So next one is add load. This will create the path between the 2 points. They will create the path from here to there and from there to here, yeah, two-way point. And next one is we use the Dijkstra algorithm, yeah. That is the I think the most popular shortest path algorithm for solving the shortest path, yeah. So the Dijkstra algorithm we will make the all paths to infinity except the start one, and we will use the priority queue to order it in the urgency, yeah. So we will dive into the loop, and if we use the next move, that is the nearby path, if the weight past the current distance is the distance is less than the distance of the nearby, they will updating the distance nearby to distance and the previous location nearby to current location, and they will insert this move, that is the distance and the nearby path, to the priority queue, yeah. And they will do looping again to make sure that is shortest path already. So when we have the shortest path, they will looping in this from the end to the start, and we will have the path that going from start to end to start, yeah. And then we will return the path and the distance, shortest path and the shortest distance from start to the end, yeah. Next is the insert function. We only like to insert it into the priority queue and pop it from the priority queue. So we focusing on the print route. The print route is we will print the optimal route, that is from start to end, that is the shortest path already, and the total distance with the traffic and urgency, yeah, with the shortest path already. And next is handle inventory update. So this is if there is the status stock available is available, they will decrease the stock of that order product name, yeah. And we use the function from the inventory class, that is replenish stock, to decreasing the stock. But if the status is not available, they will show the stock unavailable for this product name at that location for order ID. That this one is class order or order class. The initial function is we have an order ID, the urgency, the status that stock are available or not, and the location. Also we have the product name, yeah. And the next function is LT. LT is only the function to make sure that we will order from less urgency to the most urgency, yeah. The next is class of priority queue. So we use the min heap to make the priority queue. The first one is the initial function. We use that in the list, yeah. Next one is insert. We append order in the min heap, yeah, with the list, and just heapify up them to adjust the min heap to be ordered in less urgency to the most in urgency. Yeah. For next one is pop. So if there is no order in the heap, they will return none. If one order, they will return the first one, that is self.heap.pop. Yeah. So but if the have the many order in it, it will swap the first one, that is the root, and the last one of the heap. When they swap, they will pop up the uh, root one and heapify down them and return the root. Yeah. Next is top. We will return the head of the heap. Yeah. Next is empty. That is the function that check if the heap is empty or not. So next is the search function. The search function is for linear search. If this order is in the heap, if it will return the order, but it's not, it will return none. Next one is delete. We will like finding this order in the heap also, and if it order in the heap, they will swap that order and the last one, and they will pop that one out and heapify down in the location that we swap. Yeah. And return true if it in this order is in the heap, but if not, they return false. Heapify up, we use this function to adjust when we insert the order into the priority queue. Yeah. And the heapify down we use it will use when we want to delete the node, or we want to delete some order from the priority queue. Yeah. The swap function is like a swap to variable ij, and the print queue is like we will print the order ID, product, and urgency variable location from the less urgency to the most urgency. Yeah, with order in order ID also. So next one is location class. This will storing the location ID, name, and coordinate. Coordinate is just like XY coordinate or latitude, longitude. And next one is for REPR function. This is when you like to print the location, ID, name, coordinate of the location, we use this. Yeah. And the last one is the knapsack function. So knapsack function is from the dynamic programming method that we use in competitive programming, or just like the algorithm to make the highest value in the max capacity that we have. So they will like storing the DP table with 0, and the table is about n plus 1 time capacity plus 1 table, yeah, in it. And they will just like use this algorithm to have the maximum value with the with the capacity that we have. Yeah. To demonstrate it, we will run this first to initiate the project, and this example code for like we used to insert the order. Yeah, searching the order, and we will delete the order. Okay, when we run this code, they will show like this. So they will like sorted by the urgency. Yeah, let's to the most one, and this pop. Yeah, if we pop it, yeah, they will return the highest priority, that is the list of urgency, that is product phone. Yeah. Then if this is pop up, pop out, they will like we call top one. The top one will change to B4. Yes, ID4 monitor. And searching for ID3. Yeah, the ID3 will like in this. Okay, tablet they will show, and we will delete double 5. ID5 is this keyboard. When we delete ID5, they will just like this, because when we pop 2 and delete 5, they will use the heapify down to adjust the heap, and they will go like this. Okay, in this function we can like add some new, like this. We will copy down like this and print. Okay, print this, add new. Okay, when we add this, we will like order equal to this, and change the ID to 11. This is the priority of it. I will change to 2, and customer I will not change, and this MacBook. Okay, and then we will use this. This is pq.insert that will insert order to it, and don't forget to print it out. Okay, when you run again, they will add new, and this 11 ID 11 product MacBook will add in your order now. As you can see, if we have to use the top one, we can call pq.pop, and they will pop out. But if you don't want to pop out, you can call pq.top, and if you want to save, you can call pq.save, as like this. And if you want to delete, you can call pq.delete, and this is the ID of the order. Yeah, and insert is also there. You can insert in list, or you can insert each order by this. Is the route optimization. When we run this code, and when we run this code, I will use the same order as the above. This is the same order, and we will going to add it in the priority queue. And don't forget to use the location point. This is the use location function to add the location. Location, the first column is the ID of it, the second column is the name of it, and the third column is the coordinate of it, x, y, and y. Yeah, and add the location function to location 1 to 10. And don't forget to add route, because they will add the path between the two ID. This is ID1 to ID2, and ID2 to ID1. Yeah, this 10 is the third column of it. And when we add route and add location already, we will go into this process. They will like showing the process order ID that is sorted by the urgency, from less urgency to the most urgency, like this. Okay, ID2 phone with urgency 1. This is the path when we going to start to the end of it, and when the end of this, they will going to going to another order, another, and finish the last order. They will calculate the optimal route, and they will show as the path that we can go, and the shortest path that we can go, and the shortest distance that we need to use. Yeah, is optimal. Inventory management, we will run this code for the example, and when we run this code, I will use only the 4 input, and like this is I will copy from another code above, and when we setting like this, then this process will go like checking the order that's available or not. If it's not available from the order in the final inventory, or the inventory that we have now will not show the unavailable order in it. We use knapsack function. Yeah. We run this code to calculate the maximum volume that we have in the capacity we have. Okay, when we run this code and setting like this, and we setting like product name, the weight of each one, and the value of each one, and the capacity that we have, the max value is equal to knapsack function and the value that we setting, and they will print the maximum value in warehouse that we can collect it. Thank you.
So in conclusion, we use the efficiency algorithm like the priority queue, greedy, dissect, and knapsacks problem, and we hope that the system will improve fulfillment, maximum warehouse space, and reduce delivery costs while adapting to real-time change. And this solution may help the logistic companion enhance the operational efficiency, reduce costs, and increase the customer satisfactions, made it available to in the today competitive. Even though we just do a demo, but yeah, that's all we hope for. And thank you for listening to our presentation. ครับ สวัสดีครับ